So this is the final lecture of our function series. Over the past 5 lectures, we've talked about function notations, domain and range. We've talked about composite functions, the inverse function, transformations of functions, and finally, in the last lecture, we did vertex, minimum, maximum, and completing the square form. Right? Today, we are going to learn something that Cambridge really loves testing, not because it's difficult, but because it tells you everything about a quadratic before you even solve it. Now, what if I ask you a question? If I ask you that find me without really solving it, like without factorizing it, putting in the quadratic formula or etc., can you tell me whether this question has two solutions, which means that this is a function that cuts the graph at 2 points, or whether this is a function that cuts the graph at just 1 point, or whether this is a function that does not even intersect the curve, which means that it has no real solutions. Most students are going to immediately say that how can we know without solving it, right? And fair enough, but Cambridge expects you to know, and today by the end of this lecture you should be able to answer that question in under 3 to 5 seconds. So let's begin. Please write today's heading, which is quadratics 2, discriminant, intersections and inequalities. Okay, so now you already know the quadratic formula. Let's write it once, which is x is equal to minus b plus and minus under root of b squared minus 4ac upon 2a, and we did the derivation of this formula in our last lesson, right? However, I'm not interested in memorizing this entire formula today. What I'm interested in is this tiny expression b squared minus 4ac. Now, this part has a special name. You call it the discriminant, right? Discriminant, right? And if you only remember one thing from today's lecture, remember this. The discriminant does not help you solve the quadratic. It's not going to help you solve this equation, but it is going to tell you what type of a quadratic you're dealing with, right? Think of it as a report card from before the exam even begins. So just to reiterate, imagine I sketch 3 different parabolas, right? So one that cuts the horizontal axis at 2 points, which means that there are 2 roots. One that just barely touches or is tangential to the x-axis, which means that it has repeated roots or a single root, or one that does not even touch the curve, which means that it has no real solutions, right? Now, these were 3 completely different graphs. This one, and this one. Just a single root, 2 roots. This is the y-axis, and no roots at all, right? Now, these are completely different graphs, but here's the beautiful part. One expression tells you which graph you're looking at. So this discriminant b squared minus 4ac, and the value that it gets, whether it is greater than 0 or less than 0 or equal to 0, you will be able to identify whether you are dealing with this one or this one or this one. Not the whole quadratic formula, just this part. Let's see how. So case number 1. So case number 1 is where b squared minus 4ac, which I can rewrite as d, capital D, is greater than 0, right? Now, what does that actually mean? It means that when you eventually use the quadratic formula, which was, please recall that x, in order to find the roots, your quadratic formula is minus b plus and minus under root b squared minus 4ac. Now, this b squared minus 4 and then a 2a in the denominator. Now, this highlighted part right here, this is the discriminant, right? Now, if this gets you 2 values, or if this is greater than 0, then you get 2 roots. So x1 becomes minus b plus under root of discriminant over 2a, and x2, the second root, is going to be minus b minus the under root of discriminant upon 2a, right? So this gives you 2 roots, right? As you can very easily look here, right? I hope you guys are able to identify that. So you are taking the square root of a positive number here. When the discriminant is greater than 0, then you are taking the square root of a positive number. And what's the square root of a positive number? A real number. So we'll end up with 2 different values of x. Graphically, that means the parabola cuts the x-axis twice. So this one is going to be where minus b plus under root of d, which is b squared minus 4ac upon 2a. And this one is going to be minus b minus under root of d upon 2a. And do you recall from the last lesson that we said that this minimum value, the x, the value of x at which this minimum value occurs, is nowhere but minus b upon 2a. And where do we get that? We add this and this and take the middle point. So that's going to be minus b upon 2a plus minus b upon 2a. So wait a second. So that's going to be plus so no, my bad. So my this thing was minus b minus b plus root d upon 2a, and then minus b minus root d upon 2a. And then when you added that, when you add the 2 up and divide it by 2, so what do you get? So since the denominators are same here, so I can cancel these two and I get minus b minus 2b upon 2a and whole thing divided by 2. So this cancels this. So eventually I am left with minus b upon 2a. So this value is minus b upon 2a, which is the value at which the minimum or maximum value occurs, the x value where the minimum or maximum occurs. However, we already covered that in our last lecture, so we can do that later. Now, so these were two roots, 2x intercepts 2 points where y equals to 0. So whenever you see that the discriminant or the b squared minus 4ac is greater than 0, I don't even think about the formula anymore. I immediately picture a parabola crossing the x-axis twice at two distinct points, because algebra and graphs are simply two ways of describing the same thing. Similarly, in case number 2, let's say your discriminant is equal to 0, or your b squared minus 4ac is equal to 0. So recall from the formula, your roots exist at minus b plus minus under root b squared under root b squared minus 4ac upon 2a. Now if this inside the third function if this simply becomes 0, so you have a single root, right? So so this just becomes x is equal to minus b plus and minus, no, just upon 2a. So this becomes your turning point, right? This becomes a turning point as well as a root, right? So depending on whether it's a minimum type curve or a maximum type curve, if it's a minimum type, you're going to have something like this minus, and this is going to be minus b upon 2a. Or if you have a maximum type curve, or somewhere here the function is described as such, so this is going to become your minus b upon 2a if your a is negative here and if your a is positive here, as you can clearly see. Now so the quadratic so both solutions become identical, or we call it repeated roots, that there are two roots but they are repeating, right? Because the first root is minus b plus under root 0 upon 2a, and the other is minus b minus under root 0 upon 2a, which is one and the same thing, but just expressing it mathematically. There aren't two different roots or two distinct roots anymore. There's only one repeated root, but be careful with the language. Students often say one root. Cambridge usually call it two equal real roots or a repeated root. I will write it down here. Two repeated real roots or a repeated root, right? Which is a single, of course. Both mean one and the same thing, that you are going to obtain one value, right? Graphically, the parabola doesn't cross the x-axis. It's tangential, or it just kisses the x-axis here or here, right? Like this. Touches it exactly once. This point is called a tangent point. We'll use that idea repeatedly later in today's lecture. Whenever a question says the line is a tangent or the parabola touches the x-axis, which means that if you have a parabola which touches the x-axis at just one point, we right away knows that its discriminant is less than 0. Or if the question says that a parabola and the line touches exactly at one point, then we know then that if this is fx and if this is g of x, so if we are solving them together, so we will do fx minus gx whatever equal to 0, and this quadratic function that we are going to find eventually, we are going to set its discriminant equal to 0 in order to find any missing value, or just verify that it stands out to be 0 if there are no missing values, right? So in such case scenarios, whether the line is a tangent or whether the parabola touches the x-axis, which was this one at just one point, my brain would immediately whisper to me that discriminant equals 0, right? And that's the examiner's shortcut right here. Now, let's move on to case number 3. Now, case number 3 says what? It is where your discriminant is actually less than 0. Now, this is the case where the graph doesn't have any real solutions, right? Which means that if your discriminant is negative, that means that your roots do not have a real solution, right? It has a negative value inside the third form, which you're told, and you will be told until complex numbers in your P3, in your A2 math, you will be told that there are no solutions. So you write an A, right? Now, that's so we are saying that real solutions do not exist, but complex does. But let's not go there. We will just take it as it is, and we will say that no real solutions or no real roots, right? Which means that either your graph goes like this or goes like this up. So if your graph goes like this, you will say that for every value of x, the function of x is negative for all real values of x. And if your graph goes like this, right, then you will say that for all real values of x, your graph or your function is positive, right? So in AS level, I will just reiterate that isn't a real number. When we get b squared minus 4ac, this highlighted part as a negative. However, in P3, like I told you, we do deal with those expressions as well. That is a mathematical quantity, so there are no real roots. Graphically, the parabola never, I'm just reiterating the fact that the parabola never reaches the x-axis. So either like this or like this, it doesn't reach the x-axis. Maybe it's completely sits above it, like in this case, or maybe completely below it. Either way, there are no x-intercepts, right? So now we have connected everything together. Positive discriminant, 2 crossings, right? Which we did here, case number 1. So this is the case of positive discriminant where there are two x-intercepts, right? Now, if the b squared minus 4ac is equal to 0, which means at 0 discriminant, it just touches the x-axis once, right? It is tangential. And if the discriminant is negative, then there are no crossings, just like in this case that we did in the third case, right? Now, notice what just happened. We never solved a single quadratic, yet we already know exactly what its graph looks like, right? I hope I'm able to make my point, and this is powerful. Cambridge notes it's powerful, which is why they ask questions that never require you to find the roots. They simply ask how many real roots, show that the curve doesn't meet the x-axis, or find the value of k for which there are 2 distinct roots. For example, you have a quadratic function 2x squared minus 5x plus 7, right, is equal to y, and you have another function y equals to a straight line, which is kx plus 5, right? Now, they may ask you that find the values of k for which there are two there are 2 intercepts, right? Or I will not put k here, I will write x plus k, let's say, in order to explain it better. Let's say your parabola is like this, and your graph, now your straight line is going to go like this. It has a gradient of 1, so it can go like this, like this, like this, like this, like this, or like this. So when we solve it together, we will do what? We are going to compare the two, right? We want the particular value of k which should be parallel to these lines, but a value of k which makes it just tangential, right? You just get a single point. So this is going to be that particular value of k, although negative in our case, right? And how do we solve that? We are going to do 2x squared. We are going to set the equations equal to each other. Minus 5x plus 7. Minus 5x plus 7. Now, right now, I do not know whether it is drawn like this. It could be drawn here. It could be drawn here somewhere, right? I'm just doing it hypothetically. Is equal to x plus k. Now, this is going to become 2x squared minus 6x plus 7 minus k equal to 0. And now this is a quadratic function, and we know that it touches the x-axis at just one point. So what are we going to do? We are going to find its discriminant b squared minus 4ac and set it up to equal to 0. So b is minus 6. So 36 minus 4a. A is 2 and c is 7 minus k equal to 0. So this is going to become 36 minus 56 and then plus 8k is equal to 0. So k is going to be 5 upon 2. Right? So this is going to be the value of k. So probably my graph is not sitting here. So the graph, this parabola, so this is the value of k, 5 upon 2. So the graph perhaps is something like this, and it's touching it at one point only. Okay, so whenever Cambridge simply asks you how many real roots, show that the curve doesn't meet the x-axis, or find the values of k for which there are two distinct roots. We did a case of for a single or a repeated root or repeated real roots, right? And if you're still reaching for the quadratic formula every single time, I mean, if you are putting it x is equal to minus b plus minus under root b squared minus 4ac upon 2a, then of course there was no use of that in this question of ours, which we did right here, right? That there were two functions, and we need to find the values of k for which this line is tangential to this parabola, right? So if you're doing that, you are making the paper much harder than it needs to be, right? So let's test this idea once more, and let's do it immediately without solving. Tell me about this equation. So x squared minus 6x plus 5 equal to 0, right? Don't solve it, just tell me. So I want you to pause the video and tell me whether it has a single solution, two solutions, or no solutions at all. So what I'm going to do I'm going to do b squared minus 4ac. I'm going to determine through the value that I obtain here that whether the graph has two solutions, a single solution, or no solution. So this is going to be minus x squared b squared minus 4ac. So this is 36 minus 20. So this quantity is greater than 0. So I will have two solutions. And because this value is 1, which is greater than 0, so my a is greater than 0, therefore it is a minimum type curve as well, right? So I can now factorize it. So this is x squared minus 5x minus x plus 5 equal to 0. So this is x minus 5 minus 1 x minus 5. So I can clearly see that the graph cuts the x-axis at 2 points, 1 and 5, right? I did not do a good job here. So it is going to be like this, and the minimum point is going to sit somewhere right in the middle, which is going to be at 3, right? And when you put the value of 3 here, you get 9 minus 18, which is minus 9 plus 5 is minus 4. So the y value is going to be minus 4. Just recapping from our last lecture as well. So now just look at the discriminant. You get the discriminant as as 16, right? Which is greater than 0, right? So this is positive. So it tells us that there are two distinct real roots, right? And I still don't know, I didn't know back then that what they were, but then I solved it by factorization, and I found out that one existed at 5, the other at 1, right? Now let's try another one. Let's say you have x squared minus 8x plus 16 equal to 0. So I can clearly see that this is x. So now this is b squared. Okay, so this is nothing but x minus 4 whole square, right? So the graph is simply here at 4. So this is so its discriminant ought to be 0, right? So now let's see, discriminant b squared. So 64 minus 4 times 16 is just 64 again. So this indeed is 0, therefore it is the case, right? Now we just computed the discriminant, and we immediately found out that the discriminant value was equal to 0. So we will say that there are two equal real roots. The graph just touches the x-axis, and it touches it at 4, 0, right? Now if we do one more, which is x squared plus 4x plus 8 equal to 0, the discriminant is going to be equal to let's change color. So b squared is 16 minus 4 times 8 times 1, which is a. So this is less than 0 clearly. Now this graph doesn't touch the x-axis, right? And if you go about on solving it, of course your b squared minus 4ac is already less than 0. So your surd value is going to be the function inside the surd is going to be negative. Therefore you cannot, or the value inside your surd in the quadratic formula is going to be negative. Therefore you will not obtain any solutions. And now if I try to do it through completed square form, so this is going to be x plus 2 whole square minus 4 plus 8. So this is going to be x plus 2 whole square plus 4. Now what does this show us? This shows us that the turning point exists at minus 2, 4. And this is a minimum type curve because the coefficient of this bracket is positive. Therefore the graph is a minimum type curve that is unable to reach to the x-axis. Therefore there are no solutions to this function, right? So 3 questions, less than a minute, my explanation took a lot more time, but you will just take less than a minute, no quadratic formula, and that's exactly how the examiner is going to want you to think in your P1 paper this October, November, or your May, June. Now comes the interesting part. The discriminant isn't just used to classify quadratics, it's also the fastest way to solve one of Cambridge's favorite question types, which is the find the value of k, which we just did there. So even if you had x squared minus kx plus 5 is equal to y is a parabola, which you cannot right now plot, and the other function is y equals to 3x minus 8, right? And it asks you to find the value of k for which there are two roots. Then you are going to, so let's say that this is fx, let's say that this is gx, so you are going to set them equal to each other because you are trying to find the roots, but you cannot solve it because you have an unknown in k. So you are going to do fx minus gx, which is still is going to give you a quadratic. So this is a quadratic or a polynomial of degree 2. So now you can apply the quadratic formula, of which inside, I mean, I'm just saying you can apply the quadratic formula because I want you to imagine this part, b squared minus 4ac, and because there are two roots, the b squared minus 4ac, which is going to be in terms of k, has to be greater than 0, right? So now in the next after a while, I'm going to explain to you how to solve those type of equations as well. I did a case earlier in this video. I will do a few more. Okay, so now let us going to look at this Cambridge, a genuine Cambridge style question. So let's say that you have a straight line y is equal to x plus k and a parabola which is y equals to x squared plus 5x plus 2. Now, you don't have to panic when you see two equations. We have already covered that earlier. But students often think, oh no, simultaneous equations. Actually, this entire question is about the discriminant. No simultaneous solutions, nothing. The words and sorry, I missed one thing. So we are saying that these two functions are tangent to each other, which means that we are going to obtain a single solution. Therefore, your brain must quietly whisper to you, but a very strong whisper, that its discriminant has to be equal to 0, right? So now you may, so this entire question is just about the discriminant. The words is a tangent are the biggest clue in the entire question. Whether you see the word tangent or I want a little alarm bell to ring inside your head. Tangent, discriminant equals to 0, and let's prove why. A point of intersection must satisfy both equations, right? So that the solution must exist here and the solution must exist here as well, right? I'm just getting into slightly more depth. So instead of solving them separately, I'm going to substitute the line into the curve. So I can substitute it right here. So this becomes x plus k. Let me change color. I don't like black color. So x plus k is equal to x squared plus 5x plus 2, and taking everything to one side, this becomes plus 4x plus 2 minus k. So 2 minus k is my c, plus 4 is my b, and 1 is my a, right? Now, we have collected everything onto one side and equated it to 0. Now, you need to pause here. Notice what we have created. We don't actually care about solving the quadratic. We are not, I mean, we are not going to do that. We are going to extract a piece of quadratic formula out, and we will transform the geometry into algebra, right? So the number of intersection points between the line and the parabola, exactly the number of real solutions of this quadratic, right? And that is the key idea. Now, write this somewhere in your notes, that intersection questions, they become discriminant questions after substitution. First, you have to do substitution, and then you will apply discriminant, right? Whether that's greater than 0 in the case of two roots, or equal to 0 if tangential, or no roots in the case of less than 0, right? This sentence alone is worth quite a few marks in your Cambridge papers. Now let's go back to the wording. The question says is a tangent. So it is a tangent, right? A tangent means exactly one point of contact. I'm just reiterating. So just one point of intersection, exactly one repeated root. So this thing, x is equal to minus b plus minus under root b squared minus 4ac upon 2a. Now, if this highlighted part is greater than 0, I'm going to have two values of x. If this highlighted part is less than 0, then I'm going to have no solution. However, it says that there does exist a single solution. Therefore, this highlighted part ought to be equal to 0. So what I'm going to do next is I'm going to set my discriminant up. So that is going to be b squared minus 4ac is equal to 0. Now this becomes 16 minus 8 plus 4k is equal to 0. or 4k is equal to negative 8, or k is equal to negative 2. So for the value k is equal to negative 2, if this k is negative 2, we are going to have a tangent. So if the parabola is like this, for different values of k, my functions could have been, the straight lines could go like this, could go like this, could go like this, could go like this, but for a particular value of k, the graph becomes just tangential. See how all these lines are parallel to each other, right? So the gradient isn't changing, but the y-intercept, the y-intercept of this line is changing, and at y-intercept equal to -2, the line becomes tangential to the parabola, right? So uh, we have been able to solve it. Did you notice something here? At no point did we solve for x, because that was not required. They just wanted us to find the value of k for which the tangency condition is enabled, right? Tangency condition means that there does exist a solution, the discriminant is non-negative, and tangency condition also restricts us from finding two solutions. It only has a single solution, which is a very special case, right? So because the question never asked where the tangent touches, it only asked for the value of k. Now, if it were to ask where does it touch, hence find the value of x, or hence find the coordinate of the point of tangency. So you are going to do x minus 2 is equal to x squared plus 5x plus 2, x squared plus 5x plus 2. Oh, okay. So this becomes x squared plus 4x plus 4. Okay, so this is x plus 2 whole square. That's it. So x is going to be equal to negative 2, right? So we just found the tangency point as well. And if you have to find the value at which it does the y value as well, so if the x coordinate is negative 2, you can put this negative 2 either here, which is going to give you a negative 4, or here, which again is going to give you a negative 4, because y, negative 2 squared is 4, and plus 2 is plus 2, and then this is minus 6, minus 10, so this becomes negative 4 as well. So your y coordinate of this point of tangency becomes -2 comma -4. So students waste 2 pages trying to find coordinates, which is not even required and usually, but when Cambridge only wanted one parameter, the unknown parameter, right? Always read the question carefully. Now let's make the picture in our minds. Imagine the parabola. Now imagine a line, right? But we needed a line which was tangent to the curve, right? And it existed at -2, right? So one intersection. Now, so if you move it a little more upwards, this cuts. This gives you two intersections, or if you move it a little below this point, it does not have a solution. So and it eventually leaves the parabola completely again, which means that there are going to be no intersections. So can you see what's happening? The algebra, the graph, and the discriminant are all describing exactly the same event. That's why I keep saying that don't memorize formulas, understand the picture, because once you understand the picture, the algebra almost writes itself, right? Now let's now extend this idea. Suppose Cambridge changes just one word. They're saying that instead of saying is a tangent, they now say cuts the curve at two distinct points. Now you are going to do b squared minus 4ac is greater than 0, right? Everything remains identical. The only thing that changes is this. Now we don't want a repeated root. We want two different real roots, right? So right here where we were doing, so now you can see that for all values greater than -2, here, sorry, right here. So for all values greater than -2, the graph is going to move upwards. Sorry, yeah. Let me draw a parallel line again. So this gives me two solutions. This gives me two solutions, right? So the answer must be k is greater than -2. But let's see. So when I try to solve it, so this becomes, I just put greater than 0, greater than 0. This becomes greater than 0. And this becomes greater than -2, right? Can you see? Very simple. So exactly the same substitution, exactly the same quadratic, exactly the same coefficients, bringing everything to one side. Only the inequality changes. That tiny symbol is often worth 3 or 4 marks. So let's try once. Find the values of k for which y equals to kx minus 1 intersects y equals to x squared minus 2x at two distinct points the alarm is going off, and it is saying that discriminant greater than 0 because there are two distinct or non-repeated real roots, right? Again, I'm not thinking about graphs yet. I'm thinking substitute first. So I'm going to solve it simultaneously. So x squared minus 2x minus kx minus plus 1 equal to 0. So this becomes x squared plus x minus 2 minus k plus 1 is equal to 0. Now this should be greater than 0, and we have done inequalities. So this becomes b squared, which is 4 plus 4k plus k squared minus 4ac, which is 1 and c is 1, is greater than 0. So this is my b squared, this is my 4, this is my a, this is my c, and it is greater than 0 because there are two distinct real roots, right? Now, what is this going to give me? So this is going to give me, so this is minus 4, this is plus 4, so this is going to get cancelled. So k plus 4k is greater than 0. So this is 5k is greater than 0. Is it? No. This was a k squared, right? So this is k squared plus 4k. So I will take k common. So this is k plus 4 is greater than 0. Now I can see that this function of k is greater than 0, and its roots are at 0 and minus 4. So if this is k, this is function of k, the roots, and it is a minimum type because k has a positive constant coefficient. So the function is something like this. So this is minus 4 and this is 0, and it is saying that this function is greater than 0. So the function will be greater than 0 either here for these values, or this is going to be greater than 0 here for these values. So what are these values? So this is x is less than minus 4, not less than and equal to, because 0 is not part of it. The discriminant is strictly less than 0. So either x is less than minus 4 or x is greater than 0. And again, strict inequality, not greater than and equal to 0. No, this is not possible, right? So our answer, so this is not x, this is k, and this is k. So k is greater than 0 or k is less than minus 4. So for these two range of values, your these two graphs, this one and this one, are going to have two solutions, right? So it is as simple as that. That's a full Cambridge parameter question completed in less than 5 minutes. Now you're probably beginning to see a pattern, whether the question is about tangency, two intersections, no intersections, or even inequalities. Cambridge keeps bringing you back to the same central idea, and that's why today's lesson isn't really about the discriminant. It's about learning to recognize patterns before you start calculating it, right? So far, we've used the discriminant to answer parameter questions involving lines and parabolas, but there's another topic students often treat completely separately, which is quadratic inequalities, a small version of which I have explained to you guys here, but the truth is that they're just another way of reading the graph, and we are going to see why in a second. Now, let me ask you something. When students see a quadratic inequality, something like this, x squared minus 5x plus 11 is less than 0, right? Most of you panic. You think that this is a completely new topic, but it isn't. It's the same parabola you've been studying since yesterday, or since the last lecture, or since your GCSE or O level. The only difference is today we are asking a different question. Instead of asking what are the roots, instead of asking where are the roots at exactly the points, we are now asking where is the graph, above or below the x-axis? In this one, below the x-axis. So if the two roots are here, the graph below the x-axis lie right here. So you are going to take this range between a and b. So you will say that x lies between b and a, right? So it is as simple as that, nothing more. Now let's take an example. We are going to solve, let's do a proper question. X squared minus 5x plus 6. So this is an entire function, and we are going to find the values of k for which this entire function is above the x-axis. Now before writing a single line, I already know I'm dealing with a graph. So the first question I ask myself is, what are the roots? Because if the function has to be greater than 0, I must know, so there are three parts. So the first part is below the x-axis. The second part is on the x-axis, which are the roots. And the third part is above the x-axis, which is the blue part, right? So right now we are interested in the blue part. So for the blue part, I ought to have these roots b and a. So I need to solve it first. So this becomes x squared minus 3x minus 2x plus 6 is greater than 0. So I've got two roots. One is 3 and one is 2. So I will say that for greater than 0, I'm interested in this blue part. So this has to be greater than 3 and this has to be less than 2. So I will, and they cannot coexist. So I will write it as x is either greater than 3 or x is less than 2 where the graph is above the x-axis, right? So nothing fancy, just enough to understand what's happening. Since the coefficient of x squared is positive, it was 1, so we had to make an upward open parabola, right? This is important because it tells me where the graph is positive. Now look carefully. Outside the roots, the graph is above the x-axis, right here and right here. These are the two regions, region 2 and region 1, right? Between the roots, it's below the x-axis. So between the roots, or I'll use yellow color, between the roots, between 3 and 2, it was below the x-axis. The function had to be less than 0, right? So where is y greater than 0? So we know exactly that where x is less than 2, region 1, or x is greater than 3, which is region 2. Finished. Now I want you to notice something. I never memorized outside, inside. I just looked at the graph. That's a huge difference. A lot of students that I come across and I explain to them or I scold them because if you're just memorizing stuff, you're not going to retain that information when you're of my age, right? I'm not that old, but yes, I am older than you. How old you guys are. So perhaps there's a difference of 2 decades between you and I. So the reason why I do remember is and am able to recall it perfectly is because the conceptual understanding was good, right? So that's the whole lot of difference. Your memorization is eventually going to fail you, right? But your understanding will not. Now let's try another. So if you had x squared minus 5x plus 6 is less than 0, and this is the same question, the same roots 3 and 2, so you will just say that x lies between 3 and 2, right? Notice how little work we actually did. One graph answered 2 questions. Now here's where Cambridge becomes interesting. Suppose the parabola opens downwards. Let's solve. Minus x squared plus 5x minus 6 is greater than 0. So the roots are going to be minus x squared and plus 2x plus 3x minus 6 is greater than 0. So first of all, I know that this is going to be a maximum type curve, first thing. So the roots are going to be minus x, and this is going to be x minus 2, and this is going to be plus 3, and this is going to be x minus 2 is greater than 0. So this is 3 minus x, and x minus 2 is greater than 0. So one root is 3, one root is 2, again 3 and 2. However, the parabola is now opening downwards, right? And if you had to find the values of x for which the graph was greater than 0, then you are now, my friend, dealing with this range, the inside range. Just one change of sign and everything completely flips over. So this range is now between 3 and 2 for which the function of x is greater than 0. I hope you are able to understand it because many students immediately try multiplying everything by -1 and changing the sign. I mean, you could do that as well, right? But in that case, so for example, I moved everything to this side. So this becomes x squared minus 5x plus 6 is now less than 0, right? So now you will do x squared minus 3x minus 2x plus 6 is less than 0. This is algebraic mastery. The previous one was graphical mastery. So this is x minus 3 and this is x minus 2. Again, the same but less than 0, right? So you are going to draw it like this at 3 and at 2. And now you are interested in less than 0. Again, you are going to get the same range, x between 3 and 2, right? That works. But before we even do that, look at the graph. Since the coefficient of x squared was negative, the parabola opened downwards, which changed everything. The graph now sits above the x-axis between the roots here. Not outside them. The roots are still 2 and 3, but because the graph is upside down, the positive region is now between them. So the answer becomes x, the range is x is between 3 and 2. Exactly the opposite of the previous example. Can you see why understanding the graph is much safer than memorizing rules? Because I always struggled with those in my ONA levels. Now let me show you another examiner trap. Suppose I ask you to solve x minus 4 whole square is less than or equal to 0. Now this graph, if you understand graphs, is simply like this. So the only value that this is going to be less than or equal to 0 is going to be at x is equal to 4, which is going to be this point function only, because beyond this point in the yellow region the graph is above, and there doesn't exist any blue region because the graph is not less than 0 or cannot be less than 0, and so that's algebra. But graphically you can clearly see that this is a squared function. So at x is equal to 4 the graph will attain its minimum value at 0, but for any other value of x that you take, the graph is always going to be positive, right? So some students are immediately going to write that x is less than or equal to 4. I'll tell you what. So what I generally, and what examiners actually generally see and comment about, what they see is that students will take under root on both the sides and they will say that x is less than and equal to 4. Absolutely wrong. I mean, this is disgustingly wrong because this just collapses the entire math. So this is completely wrong. Remember what a square does. A square can never be negative, right? The smallest it can ever be is 0, which was at x is equal to 4, right? Not less than 4, not greater than 4, exactly 4. Tiny questions like this appear in Cambridge papers because they test whether you're thinking or you're just manipulating symbols and trying to recall from your class inside, outside, greater than, less than, between the region or the region outside. Don't do that. Now let's connect everything we have learned today. The discriminant told us how many times the graph meets the x-axis, whether the graph is sitting above the x-axis or below the axis means that the discriminant is less than 0. If the graph is tangential like this or like this, it means that the discriminant is equal to 0. If the graph cuts at 2 points like this or like this, it means the discriminant is greater than 0, right? Now, intersection questions, they use the discriminant after substitution, which is important. Quadratic inequalities asked us where the graph lies above or below the x-axis. Different looking questions, but they're all asking about the same picture. The parabola never changes, only the question changes. That's one of the biggest lessons in pure mathematics. Strong students don't see 10 separate topics. They see one idea appearing in 10 different disguises or forms. So let's finish with a genuine examiner style question that combines almost everything we have discussed today. And once you can solve this comfortably, you're ready for almost every quadratic question Cambridge can throw at you. And for that, I'm wrapping my video up here. And for that, you will need to DM me on our Easy Talim channel, which is the handle of which goes by the name of Easy, EASY Talim, TALEEM, or reach out to me on WhatsApp. Drop me queries on +92 329 3028485. If you're not subscribing to the channel, you may not see us again. If you think that you like the chapter or I helped you clear your concepts, I want you to send this video to your friends who you want to help, and also drop your queries or your appreciation under the videos as well in the comment section. I also want you guys to learn a lot of stuff that I'm putting regularly on my Instagram channel, and if there are any queries that you want real-time solution for FOC, which I'm not charging you anything for, you can reach out to me on my WhatsApp, which goes by +92 329 3028 485. I'll see you guys in the next video.